Welcome the students in science class. Class 9, Unit 7, Current, Electricity and Magnetism. Topics: current, electricity, Ohm's law, resistance, conductivity, magnetic field, terrestrial magnetism, numerical. Current, electricity. The electricity generated due to flow of electrons is called current electricity. It is measured by ammeter or galvanometer. Ammeter is connected in series in electric circuit. Open circuit has switch off. Closed circuit has switch on. Electromotive force, EMF. The potential difference across the two terminals of electric source is called electromotive force. Its unit is volt. It is measured by voltmeter. It is measured in open circuit. Potential difference, PD. The difference in potential across the two terminals of electric source is called potential difference. Its unit is volt. It is measured by voltmeter. It is measured in closed circuit. Ohm's law. The current flowing in the conductor is directly proportional to the potential difference supplied across its 2 ends, while all the physical conditions are constant. Let I be the current flowing in a conductor, V be the potential difference across 2 ends of the conductor, and all the physical conditions are constant. According to Ohm's law, I is proportional to V, or V is proportional to I. Therefore, V equals to IR, where R is proportionality constant. It is known as electrical resistance. Voltmeter is always connected parallel to the source or an electric load in an electric circuit, because it has extremely high resistance. The property of a substance to resist the flow of current is called resistance. It is denoted by R. Its unit is ohm. When 1 volt potential difference is supplied and 1 ampere current flows in a circuit, the resistance of circuit is called 1 ohm. Unit of resistance are kilo ohm and mega ohm. 1000 ohm equals to 1 kilo ohm. 1000 kilo ohm equals to 1 mega ohm. Conductor. The substance which can flow electricity through it is called conductor. Example, iron, copper, etc. Because they have many free electrons to flow electricity. Insulator. The substance which cannot flow electricity through it is called insulator. Example, plastic, paper, wood, etc. Because they have no free electrons to flow electricity. Semiconductor. The substance which behaves as conductor as well as insulator is called semiconductor. Example, silicon, germanium, etc. Because they have only few free electrons to flow electricity. Factors affecting the resistance. Resistance of a conducting wire is directly proportional to the length of wire. Resistance of a conducting wire is inversely proportional to the cross-sectional area of wire. Resistance depends on nature of substance. Resistance directly proportional to the temperature. Resistance of any conductor is directly proportional to the length and inversely proportional to its area. R is proportional to L. Equation number 1. R is proportional to 1 upon A. Equation number 2. Combining equation 1 and equation 2. R is proportional to L upon A. Therefore, R equals to rho L upon A, where rho is a proportionality constant. It is called the resistivity of conductor. Its unit is ohm meter. The reciprocal of resistivity is called conductivity. Good conductors have high conductivity, and bad conductors have low conductivity. Ammeter is connected in series because it has low resistance and whole current must pass through it to measure it. Magnetism. The property developed due to open chain alignment of molecular magnet in magnet is called magnetism. Magnetic field. The region around a magnet up to which a magnet affects other magnetic substance is called magnetic field. Magnetic lines of force. The curved lines emerge from the north pole to south pole of a magnet is called magnetic lines of force. Neutral point. The point on magnetic field where the magnetic compass cannot show any fixed direction is called neutral point. When the magnet is kept showing north to geographical south, the neutral point lie up and down to the magnet. When the magnet is kept showing north to geographical north, the neutral point lie side to side of the magnet. Terrestrial magnetism. The earth itself behaves as a big magnet is called terrestrial magnetism. Therefore, a freely suspended magnet always shows north and south direction. Angle of declination. The angle made by magnetic meridian with geographical meridian is called angle of declination. Angle of declination is helpful for flying aeroplanes and sailing ships. Angle of dip. The angle made by dip needle with the horizontal plane is called angle of dip. Angle of dip becomes 0 degree at equator and 90 degree at poles. Angle of dip is 90 degree at poles because only one pole attracts the dip needle at poles. Angle of dip is 0 degree at equator because both poles attracts dip needle equally at equator. Angle of dip at Kathmandu is 42 degree. Numericals. 1. How much current flows when a bulb with 40 ohm resistance is connected in battery of 10 volt? Solution. Resistance R equals to 40 ohm. Potential difference V equals to 10 volt. Current I equals to what? We know I equals to V upon R, or I equals to 10 upon 40. Therefore, I equals to 0.25 ampere. Two. Find the resistance of the wire of motor if 15 ampere current is passed through it when 4 kilovolt potential difference is supplied in it. Solution. Current I equals to 15 ampere. Potential difference V equals to 4 kilovolt equals to 4000 volt. Resistance R equals to what? We know I equals to V upon R. Therefore, R equals to V upon I. Or R equals to 4000 upon 15. Therefore, R equals to 266.57 ohm.